Ladies and gentlemen, please welcome Tim Laverty.
Hi, good morning. Thanks for coming. I'm always excited to come to Build. I was an application developer for 10 years previous coming to Microsoft. So coming and seeing past colleagues and getting to hang out with you guys and see what you're building is always great for me. Today we're going to talk about C++ for Windows Phone, or C++ on Windows Phone. And before we dive in, I want to talk a little bit about the platform and the momentum that we're seeing. So we're seeing a pretty drastic uptick in the number of apps in the marketplace, the number of developers registered for the marketplace, and in the amount of money that folks like you are making. We also, with Windows Phone 8, have a full-featured platform. If you have an app that you want to build, then you can build it with our SDK. And then, of course, what we're here to talk about, with Windows Phone 8, you have C++ support. So about 2 years ago, I started to work on the Windows Phone team. I started to work on planning the Windows Phone native and gaming platform. And in June of that year, June of, I think, 2011, I was having lunch with a friend of mine who works for 343 at Microsoft on the Halo series. My friend's a hardcore C++ programmer. He's a game dev. And he was telling me about how he'd spent this weekend programming, and it was kind of this programming binge where he built a Space Invaders game. How many people have played Space Invaders? Okay, great. So a lot of oldsters just like me. Great. So I mean, it was super exciting to talk to him about this because this was the kind of development or the kind of app that I wanted to see come to Windows Phone. So I asked him, I said, well, what would it take to bring your app to Windows Phone? And his response was almost immediate. It was pretty much instantaneous. He said, hey, you guys have to give me C++ support. I have to have native support. And as I dug in with him, he really had 3 reasons that he needed native support. And one was, it was his skill set. And it was what he was comfortable with. But the big thing is being able to take this game and port it almost as a whole to Windows Phone was critical for him. It was really challenging for him to take his C++ app or his C++ game and port it to C# when coming to Windows Phone. So really, it was portability. The second thing was reuse. He had a whole set of components that he consistently used for error handling, for logging. They were all written in C++. He wanted to be able to reuse those components on Windows Phone. So very similar to portability. And then the third thing ties into what his skill set was performance. He knew the language really well. He needed the fine level of control that he had with C++. And he needed native in order to tune from a performance perspective. So my conversation with him was great, and this was feedback that came back to the team as we were planning and laying out our plans for native and our plans for game development. So since launch last October, a whole host of apps and games have shipped on Windows Phone 8. They're in the store now. These range from games like Boom Brigade or Angry Birds Star Wars or Temple Run, which uses the Unity game engine. And outside of games, you have a host of applications around photos and also music, like Slacker Radio is up here. So it's not just about games when you think about native. It's a whole set of scenarios that are enabled with native code support on the phone. So without further ado, welcome back to C++. There are really 4 main things that you need to have to understand or to be able to make progress with what you need to do on Windows Phone when you're writing native code. The 4 things are basics of how and where is C++ supported. Second, I'll talk a little bit about when and why we would recommend you use C++. Then third, I'll talk a little bit about WinRT. When I first started to look at WinRT and thinking from my perspective as a C++ developer, I didn't really see why I would need to actually know anything about it. And I'll dig into that during the session, why I think you should understand at least the basics of the Windows Phone runtime. And then last, I'll give some examples of sharing C++ code across platforms. So across iOS, across Android, across Windows, and then to Windows Phone, obviously. OK, first, we'll talk a little bit about how and where C++ for Windows Phone. So on the left, you see a C Primer Plus book. I took a photo of this book. This is a book that I bought in like 1992 or so. On the right, you see a C++ Primer Plus, it's kind of a mouthful, C++ Primer Plus book. So the reason that I put these books up here, these are good books for spinning up and understanding the basics of C and C++. And I put the books up here to say, hey, the skills that you have, the C++ knowledge that you have is directly applicable to Windows Phone. We haven't done anything to wrap the C++ support on Windows Phone. We're not buffering you. The control that you are used to when writing C++ code for a platform is what you have on Windows Phone. It is the same. So in essence, it is C++ as you know it. So more about how. Windows Phone C++ support can be used in any Windows Phone app. From XAML applications can call into C++. And I'll talk about how that actually can be done. They can also leverage a couple. We have two built-in D3D C++ controls that we offer for XAML applications. You can also build a pure native app. If you do not want XAML, the CLR, loaded in RAM, if you want nothing else other than your code, your native code, you can. And I'll show an example of that in a little bit as well. To get at C++ support, you need to download the Windows Phone SDK. Visual Studio Express can be used to build C++ applications. Next, the same C++ compiler and CRT is used on Windows and Windows Phone. This makes it so it's very easy to take your C++ code written for Windows Phone and bring it to Windows, and obviously vice versa. Last, we support a subset of the C++ 11 standard. This next slide shows a sampling of C++ 11 features offered on Windows Phone. They range through lambdas, null pointer, the long type, etc. At the bottom of this slide, you'll see a link. You see a link to a blog post. This blog post digs into each of the items that I have listed in this table, how they're supported on Windows and Windows Phone. It also talks about the C++ 11 standard support in general. So I would recommend that for more detail on C++ 11 standard support, that you take a look at this post. OK, so here I'd like to switch gears. We're going to hop over to my demo machine. And I'd like to give a quick tour of where C++ support is offered inside of Visual Studio. And we'll look at we'll build a very small pure native application. OK, so the first spot I'm going to show, which will be a little counterintuitive, is underneath the C# node. So underneath the C# node, there is actually a template that allows you to get to native code built in. This is the Windows Phone XAML and Direct3D app. What this application does is this template is built for, is it's basically for building a XAML app and then embedding a D3D control inside of it, just for, say, rendering D3D or a video inside of a XAML scene. Underneath the C++ node is really where most of the action is. You'll notice this first template. Instead of XAML with D3D, this is D3D with XAML. These two templates are very similar. Both of them are XAML apps. One uses a drawing surface control, which you can think of like a cutout in a scene for D3D. The other is a full screen background control. Okay. Other templates in here, a static lib project, a DLL project, and I'll show where both of these can be used in Windows Phone apps. They need to be called from a WinRT component. They cannot be used directly from a XAML application. Next, we have our Windows Phone runtime component. And a little bit later, I'll show how to build a XAML app. and call C++ code, you have to use a WinRT component. I'll show how to use a XAML app calling into a WinRT component inside of Visual Studio a little bit later. And then last, we have a pure native template. So this template does not use any managed code. No CLR is loaded in your process. This is pure native. So I'm going to go ahead and create our pure native project. And the first thing I'll show is I'll show properties for this project. So if you're a C++ developer for Windows, or if you've ever written a C++ program, you likely are used to having a set of compiler options. Being able to get to your linker settings and add dependencies on additional static libs, etc. Everything here should be very familiar. This is exactly what you should be used to writing other C++ programs. There's no differences here, really. This template, and I'm going to go ahead and run it while I talk a little bit about it. And I'll walk through some of the details of the code in just a second. So the template looks deceptively simple. So all the template does is pops up a cube and spins that cube. So some of the things you can think, and this is where some of the complexity comes to light here, are one, we're hooking into the app model. So we're hooking into on starting, suspending, resume, the Windows Phone lifecycle for an application. We must be initializing D3D because we're drawing pixels on screen. We're creating the vertexes for the cube that you see up here. We're moving them and spinning them. We do that through D3D and using pixel shaders and vertex shaders, both. Windows Phone offers full programmable shader capabilities. And then last, we're using I/O, and there are also hooks for input inside of this template. So I'll walk through some of the code here concept-wise. So the shaders that we ship in box, or in the template, we have a pixel shader, we have a vertex shader. Both of these are relatively simple. Our basic timer is used for our application loop or our game loop. D3D base, these files here, are used to initialize D3D. So this should give you a feel for how to get bootstrapped if you want to get pixels on screen, so getting D3D started. This DirectX helper, in a sense, I think it's a little bit misnamed. It's really about file I/O. And I'll show this in just a second, but what this file contains is really how do you use async I/O, and we use it a little bit later to load our shaders from disk. These cube renderer, CPP and header files. So note here, we're using the read data async. These are what we just looked at, the file I/O helpers. These load our shaders from disk. And then from there, these cube renderer files lay out the vertexes for the cube, for rendering it, and then for spinning it. Okay, so the real meat of what's happening in here and how you hook to the OS and how you get input is in these two files. Phone Direct3D app 79 in this case, CPP and header. So opening these up, you'll see functions like you would expect for hooking into the OS. You have an init. You have a set window here. We have our application loop, or our run loop. For our timer, for updating our world, for rendering and for presenting. This process events function tells Windows Phone when you want input to be processed. So it's basically telling the system, go process my input. So you have direct control over when input gets processed. Here are functions on pointer pressed, on pointer moved, on pointer released. These are controlling what you do with the input when it comes in. So the way that you get an input is by using the Windows UI input pointer point in this case. And here, all I'm doing is pulling the current point off of this args parameter. So this args parameter comes in with our current point. Forgot my hat. Sorry. So I'll stop and call that out. So this hat is a WinRT concept. Is everyone familiar with ref new and hat? Can I get a show of hands if you've seen ref new or hat? Okay, so about half the room. So all this hat is saying is hey, I'm a smart pointer. Please do my ref counting for me for instances of this. So in this case, I'm pulling this pointer point off here, and then I can get at really anything I want about that point. I can pull its X position or its Y position. I can pull its frame. And using this, I could build my own gesture recognizer. I could do whatever I wanted with input. I control when input gets processed, and you can also control what you do with that input. So you can pull it in and build your own stuff based off of it. So a little lower, I was talking about the application model concepts. So here we have on activated, on suspending. So in on suspending, you want to do things like, well, if you have state that you would like to save for when your app is activated, in case it gets tombstoned, you would actually write that code here in on suspending. Very similar to what you do with a managed app. And then, of course, on resuming, where you're going to reinflate that state as needed. So the purpose of this template is really, it's not a full-featured application. This is really there to bootstrap you. This is to give you a safe harbor for how do I hook into the app model? How do you get input? How do you initialize D3D? How do you get pixels on screen? What do shaders look like inside of a Windows Phone app? So the idea behind most of these templates in this case is really to spin you up and get you bootstrapped. Okay, can we go back to slides? Okay, so I hope that gives you a quick tour. There were 6 project templates. They ranged through XAML apps, through the pure native app that we just looked at in a little bit more detail. So more on where. A little bit of this is review. So every Windows Phone 8 app can use C++. So every Windows Phone 8 app can use native code, whether you're a XAML app or whether you're pure native. C++ libraries can be used. You can use load library from package to load DLLs. You can link to static libs, as I showed in project properties. This said, not necessarily all apps need to use native code. I sometimes get this question from XAML developers. Well, where and how should I integrate C++ into my app? And my response is usually, if you're happy with your application, if you've built a XAML app and you like it, it performs great, it's selling well, it's doing what you want, then keep it there. Keep it in XAML. C++ on Windows Phone was really added for the 3 main reasons. I mentioned these before when I was telling the story of my having lunch with my friend that works on Halo. So first is portability. I want to be able to take my apps from these other platforms and bring them to Windows Phone with very minimal changes, if any at all. Second is reuse. I've written a C++ component. This isn't just about games. This is, hey, I might have written my C++ error handling component. I might have written a compute library for, say in 95, I wrote a compute library for a financials app. I might want to take that compute library, bring it into a Windows Phone app, and actually directly reuse it. And then last, perf. So having the fine level of control that C++ offers when is input processed, what do I do with it, is of high value. So looking at these things, there are a large number of scenarios that you can accomplish with C++ that you couldn't before. So we're super excited to have it be available in the platform for you. Okay, so a little bit about the Windows Phone runtime now. So why bother? Why learn about WinRT? This is a question I asked early on when I started to work on Windows Phone 8. And the 3 reasons here are, almost always in every application that you build, I would be very surprised if you did not use it. So the fact that you're using it says, well, you probably want to know at least the basics of it. So WinRT is used in the application model. In those unactivated, suspending events that we looked at in a pure native app that I demoed a few minutes ago, those used WinRT. So the way that we hook Windows Phone apps into the OS is using WinRT. Second, if you want to call C++ code from XAML apps, then you must use WinRT. It's the only way that we support it. So I cannot statically link C++ code into a XAML app or dynamically load a C++ library into a XAML app directly. Now, I could do this. I could say, I have my XAML app. I call into C++ code through WinRT, so it does the interop for me and does the marshalling. And then that C++ WinRT component can, of course, statically link to libs or dynamically load DLLs. Third reason you should know about WinRT is platform APIs. Our platform APIs, at least the vast majority of platform APIs built on Windows Phone, use or are built with WinRT. This ranges through location, NFC, Bluetooth, speech. If you're using really almost any platform capability for Windows Phone, you will be using WinRT. So these are good reasons to at least understand the basics of what WinRT is and how it works. Okay, so if somebody, I hear people often talk about the Windows runtime, and they usually talk about it on, I guess, really in two ways. One on the left you see up here, you can think of it as infrastructure. Well, it's core plumbing. It offers this common type system. It also offers your standard programming model. And then on the right, you see its APIs. So I just said speech, NFC, Bluetooth. So these are features that use WinRT or are built on top of WinRT that are offered for Windows Phone. The other thing that I think is interesting, how many of you, or does anyone in here write components and then ship them publicly to other developers or other application developers? Okay. I see at least 5 or 6. Good. So WinRT is a great option for building components and shipping them to other developers. If you build your WinRT component, say I build a WinRT component with C++, the WinRT, the infrastructure, will project it to C++. It will project it to C#, and it will project it to VB for free. So it's a very nice, instead of having to write my component and sell it with 3 different versions, I have actually one API that I actually build and write, and I offer it to all 3 audiences. I'm basically defining the ABI, or Application Binary Interface, and then WinRT is projecting it to C++, to C#, and to VB. Okay, so let's take a look at WinRT in action. I have 2 separate demos here. One, I'll show some basics. I'll show how to do interop. We'll build a XAML app, and then we'll call into C++ code. So it should give you a feel for the basics of what you need to do interop. And then we'll look at a Sphero demo as well. So can I get demo machine, please? Thanks. OK, so I'll create a new project, and we'll start out with the C# project. So I created a blank project on purpose. And here, all I'm going to do is drag a button onto it. So we're not going to do anything fancy. All we want to do is create a XAML app and showcase calling into C++ code for the app. So inside of the event handler for this button, if I can type, I want to call native code in here. Okay. So I need some native code to call first. So let's add a WinRT component to our solution. And again, if you're in a XAML app, the only way, your only entry point to get into C++ code is using a WinRT component. So we're going to create a new WinRT component. So here, I'm going to choose Windows Phone Runtime Component, and I'll call it Superfast Math Library. And I think I just created I don't think I created a WinRT component. Oh, yeah, I did. No. Okay, I didn't. So let's try that again. I'm going to add a new project. I'm going to choose Windows Phone Runtime Component. And I'll choose Math Component. Okay, so all this has done is it's added a WinRT component to my project. And what I'm going to do is I'm going to add a method here called add something. And then I need an implementation for said function. And I think I returned an int. Yes. Okay, so let's go ahead and build this. So all I've done so far, all we've done is we created a XAML app. We've got a button on it. We want to call native code from behind that button. We've created this C++ component. It's a WinRT component with this add something method that we want to call. So in order to do that, we need to come into our managed application and add a reference to the native component that we just created. So here you see math component. And then in the handler for that button, first let's create our component. And then let's use it. So all that's happening here is this. Our managed code walks into the button click handler. We create our WinRT component just like you would any other managed component, if you're familiar with managed code. So this is kind of this is the power, this is the glory of WinRT. I wrote my math component in C++, and it's helping me. It's projecting that C++ component so that I can access it through C#. And then I'm, of course, showing my message box. Here, I call add something, and then I toString off of it. So if I run this,
hang on a second.
Yeah, my keyboard's locked up.
Okay, so yeah, go take it.
Wow. Please. How do you like that? I had to copy and paste the in paren. Hopefully it'll run. Okay, so if I run this, all that's happening here when I click the button is it's popping our message box. I'm going to go risky and put a breakpoint in here as well. So clicking this button stops in our managed code. Now, what I'd also like to do, and I want to call this out because this is one of the limitations that you'll see in VS, is notice I have a breakpoint in my native code as well. I would expect it, or I would want it to stop in both. I would also want to F11 into that native component. I would want to step into it. So here, I click the button, and notice I hit my managed breakpoint. If I try to F11, or I also have a breakpoint in the native side, if I try to F11, it does not show it. So VS 2012 does not allow mixed mode debugging yet. So we're looking at this for a future release. So if I want to actually debug into my native code from a XAML component, and this is something that you'll likely want to do, is I right-click on my project, I go to Properties, I go to Debug, and you'll notice this UI task drop-down. Right now, it says Managed Only. If I want to get at native debugging, then I switch it to native. So here, my breakpoint for my managed, or my breakpoint in my managed app isn't going to get hit. On the native side, however, it will. Now, one thing I didn't call out earlier, and I kind of meant to when we were doing our pure native demo, is the debugging capabilities that you would expect to have in C++ in Visual Studio are all present. So you have your locals, you have watch, you have your call stack. So sometimes I'll get a question of, well, did you hamper the Visual Studio experience for C++? The answer is no. Everything that you would expect to have is actually there. OK, so super simple example. We had a XAML application here. We put a button on it. In the event handler, we called into this native component we built. When we built the native component, our super fast math library that just does addition, it projected for us automatically into C# and also it would also into VB. Okay, so a little bit more complex example. So here I have a Sphero application. It's also a hybrid application or a XAML with native application. In this case, though, I'm not using D3D. All we're doing is we've got this XAML app. We want to call native code to actually communicate with the Sphero device. Can I have a show of hands? How many people are familiar with Sphero, with the Sphero? OK, so about half. So you can roughly think of this as this is a ball with a robot in it. And what we're going to do is it allows communication over Bluetooth, over RF comm. So we're going to make a Bluetooth connection to the ball, and then we're going to send it packets over that stream socket, over that RF comm socket, to tell it where to go. The way that we'll do it is we'll pull a sensor reading off of the accelerometer in the phone, and we'll tell it, well, when I tilt forward, I want you to roll forward, back, left, right, etc. So all of this could be done in just a managed app. Managed apps have access to Bluetooth. They have access to the WinRT Stream Socket API. But the super cool thing about this particular app is I didn't have to write this Sphero communicator or this Sphero packet file. These came from the Sphero SDK. So this is a great example of portability and reuse from an SDK. You see this across, there are a number of other examples of this. You see this across SQLite, which I'll show a little bit later. You see it across, a few months ago, I showed demos of a Parrot quadcopter, where we took their SDK, and because of the C++ support that Windows Phone offers, we're able to take that SDK as is, bring it to Windows Phone, and build it and use it with some minor tweaks occasionally. So in this case, this packet code for packets that you want to exchange with the Sphero device, I did not write this. I took this from the Sphero SDK, from the Sphero examples, and directly reused it. Some of this communicator code we did write. Some of it uses stream sockets and so on. But in large part, this C++ component is using the Sphero SDK and the Sphero code. So again, this is portability and reuse. So I'm going to go ahead and, can I get Wolf Vision real quick? Now everyone knows my unlock password. OK. So I'm going to go ahead and deploy the project. I was told earlier that a different Sphero demo totally crashed and burned because someone took control of the Sphero. So if it even connects to it, then I'm gonna call it success. So once the Sphero app is deployed, I'm gonna go ahead and run it. And then to turn the Sphero on, you shake it. And I'll connect to the Sphero, hopefully. Yes. Okay. So right now it's asking, or I'll come back under the Wolf Vision. Right now it's asking me to calibrate. So when the dot points at me, I'm going to hit go. Close enough. So here, as I tilt the device, we're pulling an accelerometer reading off of the device, creating that packet structure that you saw earlier, and then sending it to the Sphero, and it's rolling as I tell it to, kind of. I don't really want to roll it off the stage. Uh-oh. Okay. I'll still call that success. Okay. So back to demo machine, please. Okay, so again, the key things here are, this is about portability and it's about reuse. I built this pretty simple XAML front end and then reused this fairly complex C++ component that allows connectivity and control of the Sphero device. So without C++ support, it would have been far more challenging to build this kind of app. Okay, and slides, please. Great. Okay, so I hope that gives you a feel for the basics of the Windows runtime and for WinRT. You're talking about platform APIs, the primary component or way that you use to interop with XAML. Okay, a little bit about sharing C++ code across platforms. So I can write a Windows runtime component and share it with Windows 8. I can also, as in the past, as you would expect, write a static lib or write DLLs and share those with Windows 8 also. With iOS and Android, standard C and C++, OSS, and other common libraries can be shared. So if you're building an app or you're building a game, then with C++ support on Windows Phone, it's far easier to port and share that app across the platforms. Last, gaming and middleware providers. A little bit earlier, I showed Temple Run on a previous slide for an app that is shipped in the Windows Phone store. So Temple Run is built on top of the Unity gaming engine. Other engines and middleware that are built around games, Cocos 2D, Marmalade, Fmod, WWise for audio. These are very common, very popular gaming middleware components and engines that are available on Windows Phone because we offer C++ support. These engines and middleware are built with C++. They needed us to offer C++ support in order to come to Windows Phone. With Windows Phone 8, we've opened that up for them, and obviously for you. Okay, I'm going to go back to demo, and I'll show a demo of using SQLite on Windows Phone. So SQLite is a pretty common mobile store at this point for relational databases. I've seen it used across Android, across Windows, etc. And it is available today for Windows Phone. So here I have a SQLite menu app. This is a relatively simple app. It has lots of tasty things that I can order. It stores those tasty things in a backend database. That backend database is SQLite. So this is kind of a theme that I've been showing is my UI, my front end, is built in XAML in this case. So it's a XAML app. My backend, so my store in this case, is built with a WinRT C++ component. My C++ component links or statically links to the SQLite DLLs as well. The first thing that you need to do to use SQLite on Windows Phone is you need to come to Tools, Extensions, and Updates. I already have this installed. You can search here for SQLite for Windows Phone and install it. Once you have it, the next thing that you need to do is add a reference to it in your project. And I already have this created as well. So under References, I have SQLite for Windows Phone 8.0. Okay. So let's dig in a little bit more to our SQLite component. This has really 4 files make up the bulk of this component. We have a statement CPP in header and a database CPP in header. They are pretty descriptive for what you would expect. Statement encapsulates or wraps executing SQL statements and walking over a return database cursor, so walking over the records that you returned from the database. Database handles connectivity. So it's going to connect to that file, or it's going to connect to that SQLite file database. So here, my connect or my open async function, and then some prepare statement and execute statement functions. So I haven't written the connection code here. So I'll pause for a minute, and one thing I wanted to call out is you have full access to the SQLite API. So we added SQLite from our extension manager. We added a reference to it. That's giving me full access to SQLite. This isn't a pared down version of SQLite. This is the real thing, okay? Okay, so the code that I've written here says, notice I use the auto keyword from C++11 standard. I'm saying, hey, go open a connection to this SQLite database at this file location. Give me a pointer back to it as well in this mDatabase variable. If it returns OK, or if it doesn't return OK, then fail. So if I run this, then you'll see our menu with our tasty things for ordering, our classic burger, our double cheese, etc. So what's happened is our XAML UI has called over or interop with our WinRT C++ component, which is statically linking with the SQLite libraries and using those libraries or wrapping those libraries to connect to a file-based database and then execute SQL statements against those databases or against that database. Here I can say add a new item, or if I want to click an item, then I could order that item or edit that item. Okay, so back to slides, please. Okay, so hopefully that gives you a good feel of how OSS components or other C++ components, static libs, DLLs, components that you might have built in the past, legacy components, can be used in Windows Phone apps. I showed it there with a XAML app. You could just as well have used SQLite from the pure native app that I showed a little bit earlier. Okay, so key takeaways for this session. If you don't remember anything other than these really 2 things. 1, C++ code can be used from any Windows Phone 8 app. So if you want to use C++, if you have a C++ component, you can use it no matter what application that you're building for Windows Phone 8. 2, the primary reasons or primary ways to think of C++ are around portability, reuse, and then best-in-class performance. So I'd ask you, I'm excited to see your apps. I want to see what you guys build. Please download the SDK and go build some native apps. So this is kind of an eye chart. I apologize. There are a number of other sessions around Windows Phone development over the last few days. You can go to Channel 9 and review these sessions. I also recognize that we're nearing the end of the conference. It's Friday. But all of these sessions are posted online. I would highly recommend going and looking at them. Then also this slide has some great developer resources. Our developer portal is pretty rich in terms of what it offers from a training perspective and a docs perspective for spinning you up on how to build Windows Phone apps. There's some great stuff up here for native, C++, also for XAML apps as well. So with that, I have, I think, about 10 to 15 minutes for questions. And I would love to hear what your questions are. And I have a phone to give away. And I'll give it to the best question that I hear. So please bring your questions.
Hi there. Just came from a session with them using the RT for network communications for sockets. And I have an application I'm liking to port that involves some VoIP. Can you comment on what sort of performance enhancements I'd see by using C++ sockets over the RT or the managed sockets library?
So the question is what kind of perf gains will I see comparing between managed sockets and the WinRT sockets library, correct? Okay. Probably for something like a Bluetooth device, I don't know that it's going to be that much of a kicker for you. For something like the Sphero, I don't think the difference would be that great in terms of the perf that you would get. Like I wouldn't switch it from a perf perspective. When I showed the Sphero device, the reason that I used native code was because someone wrote the code for me. I mean, that was an SDK, and I pulled that. I pulled those packet headers, and I pulled that communication protocol off of it. So probably from a perf perspective for devices like this, I don't think that would be I don't think that you would see that great of a speed increase. And so to go further, I haven't seen stats that show stream socket versus managed sockets either, and I don't think that there are published stats. So to a certain extent, like I think it's gonna mostly depend on what your app is, what the device that you're connecting with is. Is it over the internet? How much fine control do you want over the packets that you're creating and sending? Like, are you packing them or not? Does that answer your question?
If it involves VoIP and video overlaid of some other data, if it were you, would you start with native sockets, Berkeley sockets?
So I hear you. So follow-up question is what would you start with? Would you start with WinSock? We do offer WinSock support on Windows Phone, or BSD sockets, or the closest analog you're going to get. Would you start with WinSock, or would you use WinRT sockets? Or would you use, there's also a managed socket API. I would probably start with WinRT sockets. The semantics are very similar to what you see with WinSock. It's a really nice, clean wrapper on top of sockets. So if you needed to, you could go to WinSock if you couldn't get the perf that you wanted. And it's portable, which is really great between Windows and Windows Phone. So you could write your VoIP app, and then most likely it's going to run on Windows and Windows Phone after. Okay. Other questions?
Yes, I have a question here. Kind of close, sorry. You mentioned being able to load DLLs dynamically. Mm-hmm. What sort of issues are you looking at with that and shipping native code DLLs when it comes to releasing this through the Windows Store?
So the question is, I think the question is, hey, you said that you could load DLLs into an app, and what kind of issues would you be scared of when loading those DLLs inside of a store application. Do you mean from a security perspective or strictly from a functionality perspective?
It's my understanding that when you applied for getting your app certified for the store, that they don't let you ship straight C code or C++ DLLs.
So in the Windows Phone store, we do let you ship straight C or C++ DLLs. Just like I showed today, well, mostly what I showed was WinRT components that are C++. I also statically linked to the SQLite C libraries. Now, if I was going to ship that app, what I would do is I would package that app up into a ZAP. Those DLLs would ship as part of that ZAP. So they would ship as part of the app. Applications in the Windows Phone store can load, it's actually load library, I think load library from package, if I'm not mistaken. They can load library on DLLs that are inside of their application only. From a security perspective as well, all of this code, whether it's native or whether it's managed, is running inside of the same security chamber. So it has the exact same security restrictions that you would have with the managed app. There's absolutely no difference here. For Windows Phone, you can ship C++ and C DLLs as long as they ship as part of your application package, and you can dynamically load them.
It was my understanding under Windows 8, not Windows Phone, that you're not allowed to do that. So it's different? Mm-hmm. Okay, thank you.
So, sorry, you're asking, can you in Windows 8? Well, I think so. I hear a yes over here. I'm relatively certain that it works the same as Windows Phone. If you want to, then come up right after we finish questions, and I'll loop back with you over email just to confirm. But I'm relatively certain it's the same.
Okay, thanks.
Yep. Other questions?
Yeah, you showed us several scenarios where you call the C++ code from the XAML code, and is it possible to call it in opposite direction? If, let's say, from C++ code, I want to show a message box, how do I do that?
That's a great question. So the question is if I'm in, so the question is basically this. I write a managed app, I can call C++ code, and I showed that through a WinRT component. The question here, though, was if I write a native component, can I call managed code from there? So the answer to this is yes, but there are limitations. The limitations sum out to basically this, is if I write a pure native app, you just can't do it. I have to start with a hybrid app, with a XAML app. From that XAML app, I can call into a WinRT component, and from that WinRT component, I can call back to native code. The way that I typically have seen that done is that XAML app gives the WinRT component a pointer, usually to gives the WinRT component a pointer, and then that WinRT component calls back using that pointer. Does that answer your question?
Yeah.
Okay. Next question. Yeah.
I got a question here. So in the past, we'd heard some guidance about using C++/CX for some of your C++ code, and then trying to make the main body of your C++ code not use the /CX. Does that guidance still apply?
I think that, so the question is what is guidance around using WinRT or using CX when you're building your C++ components? Should you use it everywhere, or should you only use it some part of the time? So usually the answer that we give to that, and this does still apply, is use CX or use WRL if you want finer control. So use WinRT at your boundaries, so at your interface boundaries. Once you're inside your C++ component, do whatever you're comfortable with. So if you come from a C background, you want to use regular C calling conventions, C++ calling conventions. You want to link to DLLs, load DLLs, link to static libs, then we probably wouldn't push you to use CX once inside. But on the boundaries, yes. Does that answer your question?
Yep. Thank you.
Great. Yep.
Currently, a lot of the samples for runtime components are very simple, very similar to the one that you gave today, where you add two numbers together.
Yep.
Are there going to be some samples added that are more complex? Maybe taking in some existing C++ open source libraries that may have hundreds of files, and how can you use those? An example is something like libjpeg. It's a very known open source image processing library, but it's very complex to try to get using inside of a WinRT component.
Right. So I think the question is, hey, your samples are too simple.
Yes.
Come on. Or I guess the question is when are you going to start rolling out more complex samples that show us how to do real stuff?
Yes.
Yeah, OK. That was partly why I showed the SQLite demo, because I think it exists in a class where it's like, that's real. Like, that's real stuff. Ditto with the Sphero sample that I showed. Like, it's a relatively complex SDK. I have just a slice of it that I showed today. It's pretty challenging to show more complex examples like that when you have an hour like we do. They'll start to roll out. Like, we're still, within a couple of years of shipping, and these samples that I showed today will all be posted to the web. Some of them are already up there. I did a build networking talk 8 months ago when we shipped. And some of those samples are a little bit more complex than some of the demoware that you see. So yes, it's coming, and we're trying. I totally get it. Yeah.
Okay, thanks.
Okay.
Are we going to get the fancy async debugging call stack stuff in Windows Phone? Because it's pretty nightmarish dealing with it today.
Right. So the question is, are you going to get all of the async debugging goodness with Windows Phone? And I think I'm supposed to say we are looking at that for a future release.
Look real hard.
Yes, and I get it that it is excruciating and that you need it. And I'm glad that you asked, because I will bring that back to the team as something that you need. Yeah, thank you.
Yeah. Contrary to managed code, when you create WinRT component, we need to choose a CPU platform. How can I be sure that my Windows Phone app will work with the future Windows Phone devices?
I'm sorry, I didn't quite get the question.
Yeah, when you create a WinRT component, you need to choose a CPU platform, ARM or Intel, for example.
Yes.
How can I be sure that my component will work on the future Windows Phone? Intel spoke about making Windows Phone, for example.
So I think that the question is if I build a WinRT component, how do I know that you're not going to break me in vNext?
Yeah.
Right? I mean, we guarantee app compat over the course of releases, and this would fall into that same category. It would be very similar to writing managed code. If I write an app, whether it be native or whether it be managed, and you ship it and it's on the Windows Phone store, then we look at that app, or we test many apps before we ship and guarantee backwards compatibility across releases. So it's kind of intrinsic in what we commit to. Does that make sense?
Yeah, but if Intel, for example, made a new Windows Phone, so this is not the same CPU instruction. So the native code can't work with that.
I see. So the question would be is if another OEM came on board and had a different processor type that they ship for Windows Phone. We partner very tightly with OEMs. So I think my response would be that should never happen, basically. Yeah.
Thank you.
Okay.
Yeah, I have a simple question. The other takeaway from the demo I got is that probably when the application is more close to the hardware, it may be another good chance to use C++. So I saw the Lego demo in the keynote. So I just, maybe this is not quite related here. I just want to know, are those example code will be published? Or do you know if those code are written in C++?
So make sure I understand the question. You're asking, hey, you saw a demo of a Mindstorm kit or a Lego robot being controlled from a phone, correct?
Yeah.
And you want to know if the sample code for that is going to be published?
Yeah.
Okay, great. So the answer to that is yes, it's going to be published, and it is. So I did a networking session last October or so at Build, search for Tim Laverty networking build, and then off of there you can link to a Codeplex site that has the samples that I use. I built an application that connects to a Mindstorm kit, connects to a robot, and rolls that robot around. Very similar to what I showed, very similar to Sphero. The code actually is quite similar, other than the obvious, the protocol is different and so on, but they both use StreamSockets. So that code is available. It uses RFCOM, or it's SPP over RFCOM. So you can go download it today. So it's out there.
Okay.
For a pure native app compared to a hybrid app, what kind of a performance gains do you see for a startup and memory footprint, etc.? And also, could I render XAML in the pure native app in any way?
So the question is compare perf between XAML and pure native. And then the second question is if I'm pure native, can I get to XAML? So answer to the second question is no, unfortunately. No, at least not today. I'd be curious, talking to you after the session, whether you would want to and why you would want to, and why you wouldn't be able to go XAML to native and get what you needed. So I'd be really curious to hear your scenario.
Yeah.
Your first question around compare perf between XAML and pure native, it's a great question. We don't have official stats, and it's so highly dependent. Like, what are you doing with the CLR? Are you loading thousands of objects into RAM? If you look at the very, very basics, and any of us could actually do this under a profiler, is, well, create a bare bones native app and a bare bones XAML app. Do nothing other than just maybe show one XAML page. I think that the CLR is somewhere around 5 to 10 megs of RAM. Startup is not, startup is almost, you can't really differentiate. Like, they both come up really quick. The XAML runtime has been tuned and tuned and tuned and tuned for these kind of scenarios, and the CLR, obviously, for memory consumption as well. These are pretty mature frameworks. So they do a good job. I mean, they obviously don't offer you the fine level of control. They just give you the power of having a UI framework as well. So I don't know that I gave you a great answer.
It's a good answer, because
Okay.
you can optimize your XAML startup pretty much and lazy load things. So
Yeah.
yeah.
Okay, great.
Thank you.
Hi. We actually have an SDK which is written in C and C++ now, and we have existing C# wrapper around it, which uses pinvoke and DLL import to get access to native code. So I was wondering if should I just drop that for Windows app support, Windows Phone application development support. If I want to expose that, should I go in RT component way, or is there a way I can still support C# wrapper and then have it exposed to Windows Phone?
So I think the question is hey, I have some static libs or DLLs. I wrapped them with a C# component that pinvokes into them, so it handles all. Okay, so we don't support pinvoke for Windows Phone 8. So you would have to, if you wanted to get access to them, you would have to get to them through a WinRT component. So I would recommend building probably a very similar WinRT wrapper to your C# wrapper that can, you don't have to pinvoke obviously, but can load your DLLs and call your, link into your static libs.
If the DLL is just, I have the source, C++ source, right? So I just drop it into that component and then recompile it. I probably don't even need to do anything else.
Yeah, absolutely. Yeah. The thing that you'll need to do is the same interface, like you'll need your XAML code, your C# code, to call through WinRT to get to those DLLs and libs, right? So you'll need that marshalling layer still. Like you'll need some entry point to get to them. So very similar to what I did today in the basics of WinRT demo. And this is recorded and online, so you can take a look. And there are a number of samples that show how to do the basics of this, but you basically go from C#, create a WinRT C++ component to your facade or your wrapper, and then link into your libs or load your DLLs from there.
Right.
Make sense?
Yeah. So in this case, if I have the C++ entire source and I don't want to make it into a DLL, And if I just compile it as WinRT,
I see. So you don't want to keep them in DLLs or libs. You want to just take that source and compile it into that WinRT. Sure. C++. I mean, it's as you know it. Like C++ as you know it. Same compiler, same CRT. So yes, you could take those classes, pull them into a WinRT project, and recompile them if you so desired. If they're already created, unit tested, nicely encapsulated, then I would probably link to them or just load them, would be my recommendation. But this is your call. Yeah.
right, and no C++ CX syntaxing or anything required for that.
No.
Seems like
no. You're not required. No. Yeah.
Go with the God mic. Pardon me, I'm so sorry to interrupt. The rest of the questions, you could work with Tim up at the front of the stage.
Yeah,
and
that
we
sounds
have
good.
to cross over to the next session.
Okay, thank you. You guys can come on up. I have business cards too,
Take
and
his mic out.
thank you.